Morning, everybody. BigStew here. Hope you're doing well. Last week, we talked about Newton's first law of motion. Just to recap, Newton's first law of motion is all about inertia. And inertia means that if an object is at rest, it wants to stay at rest until a force makes it move. And if an object is in motion, it wants to keep that same motion until a force makes it change or stop. Today we're going to start off with Newton's second law. And out of Newton's laws, this is the one that tends to give folks the most trouble because there's a little bit of math involved. Let me give you the formula. All right. The formula for Newton's second law is F equals ma. Well, right now I can see some of you looking at the screen going, well, BigStew, that didn't tell me anything. That just showed me some letters that were kind of sparkly, and it was actually a nice sign. Let me tell you a little bit more. F equals ma stands for force equals mass times acceleration. All right, the force that you need to use is equal to the mass of the object times its acceleration, how much it speeds up or slows down. Well, it still doesn't make a whole lot of sense. Let me go a little bit further. All right. A force is required to move any mass. Let me clarify something about mass. First of all, mass is not the same thing as weight. All right. Weight deals with the Earth's gravitational pull on a body. So if you're heavy, they call me BigStew for a reason, it means that the Earth likes me better. Congratulations, I'm the popular kid. How about that? Now, mass just deals with the amount of matter an object has. And whether you are an apple or an elephant or a can of shaving cream or a Wonder Woman bobblehead, if you're a grain of sand or if you're an entire continent, everything has mass. Here's where it gets interesting. The more mass you have, the more force is needed to make you move or make you stop. All right, let me give you an example. All right, we've got an example of a school bus and a smart car. Now, I've never driven a smart car, but they're very small. They almost look like you could fold them up and put them in your backpack. I have, however, driven a school bus. And there is no easy way to start off a school bus from a stop and have it go fast. Anybody who's ever ridden a school bus knows that it starts off from the start going, and it takes a little bit to speed up. Well, school buses have a lot of mass, not weight, but mass. On the average, an empty school bus has a weight of about 27,000 pounds. And then when you load it up with a bunch of kids who don't want to be on it anyway, it gets a lot heavier. Well, it also has more mass that way. So it takes a lot of force to make a school bus move. This is one reason why school buses don't get great gas mileage, is because it takes so much force to make them move. The plus side is that they can carry a lot of people at one time. You don't need as much force to make the smart car move because its mass is a lot smaller. So if you had a school bus and a smart car at a stoplight, and the school bus looks over at the smart car and the smart car looks over at the school bus, and they decide for some strange reason that they're going to race, it's pretty likely that the smart car is going to win. It doesn't need nearly as much force to get moving from that stop as the school bus does. Now, once these two vehicles get moving, it's going to take a lot more force to make that school bus stop than it will to make the smart car stop. This is where mass also comes into play. Something that has a lot more mass is harder to stop. All right? You need more force to make it stop. Imagine trying to stop a school bus with your bare hands if it were rolling down a hill compared to trying to stop a smart car. It takes a lot more force for the bus because there is more mass. All right. So your mass is tied into how much force you need. Tomorrow we're going to do some examples, but in the meantime, eat some fruit and wash your hands. Have a good day.